The formula for Taylor series is yn plus 1 equals to 1 plus, yeah, give me the formula.
I never cram
You
out.
never come out.
Nah, H.
This thing different. The formula now 1 plus h, okay, of yn prime, then plus what? H squared over 2 factorial yn prime prime
plus h cube.
H cube
3 factorial. Okay.
3
Prime over 3 factorial.
Plus we truncate it at what?
At 4.
At other 4.
But you know, say this thing they go 0.5.
Yes. I just want to do 2. I can show how 2 could take work. So the first thing to do from here now is that when n is 0, the first iteration, when n is 0, what you will get? Y of 0 plus 1, that's 1. Have you? 1 plus, what's your step length? Step length is 0.1. My h is 0.1 in this case. Have you? My n is 0, so I have y naught prime here. Plus 0.1 squared. 2 factorial is 2. Y naught of what? Prime prime. Right? Then plus 0.1 is to the power of 3. 3 factorial is 6. Yn is y naught prime prime prime. You truncate at what? You truncate at order 4. So what I need now is, how do you get y naught prime? Y naught prime prime. Y naught prime prime prime. That's the question. So you now go to, that's when you make use of the differential equation given to you. You have to recall from the question given to you. I was given y prime equals minus 2x minus y, right? And I want to look for y prime. This is my y prime, but I need to put the initial point, the initial starting point for x. Y naught simply implies y naught, right? Sorry, then let me put it here. This is my y prime equals to this. So if I want to look for y naught prime, that means automatically speaking, this my x becomes the starting point. This my y also becomes the what? Starting point. Okay, which is minus 2. What is my x naught? You get it from, we get this x naught from this.
That's minus 1.
This thing is defined as y of x naught is always equals to what? Y naught. According to the definition of first order differential equation, this is how to define the initial, they call this the initial condition, initial IVP or initial value problem, or you call it initial condition. This is the generalized form of initial condition, or you can say this is the generalized form for IVP, which is the initial value problem, IVP. So x naught is 0, y naught is what? Minus 1. So you just come here and substitute it accordingly. X naught is what? 0. Y naught is what? Minus 1. So this goes, what do you have left? Minus times minus 1.
Plus 1.
That's plus 1. So my y naught prime is what? Plus 1. Which I'll just box it out here. So we have gotten this answer now. Done. Next thing is to go and look for y naught prime. So you guys recall again from this same y prime given to us. From this same y prime, the given y prime equals minus 2x minus y, right? So I now want to look for y naught prime prime. Okay, first I need to find the second derivative, y prime prime, right? Y prime prime means differentiate this thing again, right? My y prime prime will now be equals to differentiate minus 2x. What would I give you? Minus 2, right?
Yes.
Then differentiate minus 1. Anytime we touch y, I differentiate y. I differentiated this y, that's 1. I will always remember to multiply it by what?
The y over
The y dx. But it is not really making sense if you use the y dx. We have been using y prime since morning. Okay, so I would rather write this 1 dy dx as just y prime. Do you agree with that?
Yes.
Are you flowing?
Yes.
So my second derivative now is automatically equals to minus 2 minus y prime. But I'm not looking for this. What I need is to put the starting point. So to now look for the starting point of the second derivative, automatically speaking, any variable I see here, I must turn it towards naught. Okay, if I'm using naught, you must use naught for it. So what would that be? Minus 2 minus. Do I have this already? Y prime naught? Yes, I have it initially.
Plus 1.
Which was plus 1. So if you try to subtract this together, minus 2 minus 1, minus 3. So my y naught prime prime is already equals to what? Minus 3. Done. You box it so that you can actually see it clearly when you need it. So we've gotten the answer for this. Same thing with this one too. Now the next thing is we're going to look for the third derivative.
one.
Now I want to look for the y naught prime prime.
Now you have a got there.
You know, it will not really be hard because we have not yet make use of any product tree. This equation is quite straightforward. That's why it is. That's why it is easier like that. So y prime 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 is what? We can actually get that from this.
Y prime prime, yeah.
Yeah, recall from our y prime prime, which was equals to
Minus
this, Abi. So if you now differentiate y prime prime, you have the third derivative, Abi. To differentiate the square y ds square, to give you the third
derivative.
The cube y by ds square. So differentiate this minus 2, 0.
0.
Minus is already here. Now differentiate y prime. That's y prime prime straight up.
And 1 prime prime is.
So we now need to write out we don't need this y prime prime. We need the initial point for the third derivative. So I guess Abi now y naught. So we need the y naught for the third derivative. So it's now be 0 minus y naught of what? Prime prime. And I think I already have this one before.
Yes.
I have this y naught prime prime as minus 3. As minus 3, Abi. So if you now multiply it, that will be what? Positive 3. This one is what? Positive 3. So all this is what I have just gotten. This first one, this second one, and this third
We
one.
can even do it to the fifth one.
Just substitute it here. And then use your calculator to get your final answer. You truncated that order 4. You are not considering the rest. So just this fourth thing. Then get your final. This is not hard. No. But the first result, okay, let me explain it clearly. I have to substitute it. My y1. So what will my y1 now? My y1 is now equals to, according to the formula, 1 plus step length 0.1. 0.1 of the first result of y naught prime, which is 1, right? Then plus 0.1 squared over 2 factorial, which is 2. What's my y prime prime naught? Minus 3. Right? And then plus 0.1 raised to the power of 3 over 3 factorial 6. I got this one as positive 3. And you truncated at what? Order 4. So my y1 now is equals to, you press all this in the calculator to get a result. How can I pause this? Pause.